A Sand County Almanac by Aldo Leopold. Part 3, A Taste for Country. Chapter 3, Round River. Section 2. Have we learned this first principle of conservation? To preserve all the parts of the land mechanism? No, because even the scientist does not yet recognize all of them. In Germany, there is a mountain called the Spessart. Its south slope bears the most significant oaks in the world. American cabinet makers, when they want the last word in quality, use Spessart oak. The north slope, which should be the better, bears an indifferent stand of Scotch pine. Why? Both slopes are part of the same state forest. Both have been managed with equally scrupulous care for 2 centuries. Why the difference? Kick up the litter under the oak, and you will see that the leaves rot almost as fast as they fall. Under the pines, though, the needles pile up as a thick duff. Decay is much slower. Why? Because in the Middle Ages, the south slope was preserved as a deer forest by a hunting bishop. The north slope was pastured, plowed, and cut by settlers, just as we do with our woodlots in Wisconsin and Iowa today. Only after this period of abuse was the north slope replanted to pines. During this period of abuse, something happened to the microscopic flora and fauna of the soil. The number of species was greatly reduced, i.e., the digestive apparatus of the soil lost some of its parts. 2 centuries of conservation have not sufficed to restore these losses. It required the modern microscope and a century of research in soil science to discover the existence of these small cogs and wheels, which determine harmony or disharmony between man and land in the Spessart. For the biotic community to survive, its internal processes must balance, else its member species would disappear. That particular communities do survive for long periods is well known. Wisconsin, for example, in 1840 had substantially the same soil, fauna, and flora as at the end of the Ice Age, i.e. 12,000 years ago. We know this because the bones of its animals and the pollens of its plants are preserved in the peat bogs. The successive strata of peats, with their differing abundance of pollens, even record the weather. Thus, around 3000 BC, an abundance of ragweed pollen indicates either a series of droughts or a great stamping of buffalo, or severe fires on the prairie. These recurring existences did not prevent the survival of the 350 kinds of birds, 90 mammals, 150 fishes, 70 reptiles, or the thousands of insects and plants. That all these should survive as an internally balanced community for so many centuries shows an astonishing stability in the original biota. Science cannot explain the mechanisms of stability, but even a layman can see 2 of its effects. First, fertility. When extracted from rocks, circulated through such elaborate food chains that it accumulated as fast as or faster than it washed away. Second, this geological accumulation of soil fertility paralleled the diversification of flora and fauna. Stability and diversity were apparently interdependent. American conservationists, I fear, still concerned for the most part with showpieces. We have not yet learned to think in terms of small cogs and wheels. Look at our backyard, at the prairies of Iowa and southern Wisconsin. What is the most valuable part of the prairie? The fat black soil, the chernozem. Who built the chernozem? The black prairie was built by the prairie plants, 100 distinctive species of grasses, herbs, and shrubs by the prairie fungi, insects and bacteria by the prairie mammals and birds, all interlocked in one humming community of corporations and competitions, one biota. This biota, through 10,000 years of living and dying, burning and growing, praying and fleeing, freezing and thawing, built that dark and bloody ground we call prairie. Our grandfathers could not know the origin of their prairie empire. They killed off the prairie fauna, and they drove the flora to a last refuge on railroad embankments and roadsides. To our engineers, this flora is merely weeds and brush. They ply it with grader and mower. Through processes of plant succession predictable by any botanist, the prairie garden becomes a refuge for quackgrass. After the garden is gone, the highway department employs landscapers to dot the quack with elms and with artistic clumps of Scotch pine, Japanese barberry, and spirea. Conservation committees en route to some important convention whiz by and applaud this zeal for roadside beauty. Someday, we may need this prairie flora not only to look at, but to rebuild the wasting soil of prairie farms. Many species may then be missing. We have our hearts in the right place, but we do not yet recognize the small cogs and wheels. In our attempts to save the bigger cogs and wheels, we're still pretty naive. A little repentance just before a species goes over the brink is enough to make us feel virtuous. When the species is gone, we have a good cry and repeat the performance. The recent extermination of the grizzly from most of the western stock-raising states is a case in point. Yes, we still have grizzlies in the Yellowstone, but the species is ridden by imported parasites. The rifles wait on every refuge boundary. New dude ranches and new roads constantly shrink the remaining range. Every year sees fewer grizzlies on fewer ranges in fewer states. We console ourselves with the comfortable fallacy that a single museum piece will do, ignoring the clear dictum of history that a species must be saved in many places if it is to be saved at all.